Hey guys, today I will be discussing another very interesting problem on dynamic programming. So this problem often comes in many interview questions and coding rounds. So let's jump into it. So our problem for today is longest increasing subsequence. So first I will explain what the longest increasing subsequence mean. Then we will jump to the code of the longest increasing subsequence with the help of dynamic programming. Now let's say if we have set of elements like 2, 18, 12, 7, 9, 52, 16 and so on. So if we have this set of elements in an array, so what longest increasing subsequence means that we have to find the maximum length of the increasing subsequence which is there in this array. Like if we take an example of one long subsequence is 2, 18, 52. This can be one increasing subsequence. Another increasing subsequence can be 2, 12, 52 and so on. So we have to find the length of the longest increasing subsequence present in this array. So how we can solve this with the help of dynamic programming is we create an array of size exactly equal to the number of elements present in our array. Okay, now we have to fill the initial values in this new memory location which we have just created. We call this as memo because we somehow use these values again and again in our further computations. Okay, so we have initial value of all the elements in the new array as 1 because 1 represents that if we take only that element, then the longest increasing subsequence is of length 1 only because we have taken that element only. Now for finding the length of the longest increasing subsequence, what we did is we iterate two loops, I from this memory location and j from this memory location. Okay, now when I start from this memory location, j will go from starting of the map till I in the original array, and it will check whether the value present at jth location is less than value present at ith location, because we have to find the increasing subsequence. So when the value present at the jth location is less than the value of the present in ith location, then it create a increasing subsequence. Okay, now first we will check that value present at j is less than value present at I. Yes, it is less than I. So we have to fill this memory location with maximum of whatever value which is present at this location, or 1 plus the value present at jth location. Why this one? Because this value is less than this, so there is an increase in one value when we go from 2 to 18. So here we find the increasing subsequence of length 2, which is 2 and 18. Therefore this value will be changed to 2 and j is incremented. When j reaches I, we terminate the inner loop and increment the ith loop. Okay, and j is again going to start with the 0th index. Okay, now let's fill this memory location. Okay, when we start with 0th location of j, we check that the value present at j is less than the value present at I. Yes, it is less than I. So we replace this value with either the value present at this map or the maximum of 1 plus 1, that is 2. So it will update to 2. Likewise, after that we increment our j pointer and check if value present at j is less than value present at I. No, it is not. So we increment j, and j terminates because it reaches I. After that, I value is incremented to the next memory location, and j is again initialized with the 0th index. Now let's see here. The value present at j is less than value present at I. Yes, so we store value here is the current value or the maximum of 1 plus 1, which is 2. So it will be updated to 2. Okay. After that, the jth index is incremented by 1 and it will shift here. Now value present at j is less than value present at I. No, it is not. So we increment our j. So our j is now here. Now we will check value present at j is less than value present at I. No, we again increment j and it will terminate because it reaches I. Okay. After that, we increment I with this memory location, and we start our j from initial again. Okay, so let me erase this. We start our j from this memory location again. Now we check that 2 is less than 9. Yes, it is. So we increment which update this value with 1 or maximum of 1 plus 1, which is 2. So we change this value to 2. Now we increment our j and it will move to the next memory location. We check that it is less than 9. No, it is not. So increment j. 12 is less than 9. No, it is not. So increment j. 7 is less than 9. Yes, it is less than 9. So what we did is either take this value or the maximum of 1 plus the value present at the jth location, which is 2. So it resulted out to 3. So we update this value to 3. After that, we increment our ith location. So I will be now pointing here, and j is again start from the first memory location. We check that 2 is less than 52. Yes, it is. So update this value with 1 or 1 plus 1, which is 2. Increment j. J will now shift here. Check that 18 is less than 52. Yes, it is less than 52. So update this value with either 2 or 1 plus the value present at j. So it is 2 plus 1, 3. So effectively what we are doing is whatever value present at memo of I or 1 plus memo of j. This is what we are doing. If the value present at jth memory location is less than value present at ith memory location. So this is the condition which we are following and filling out this array. Now increment this jth location to this point. Now check that 12 is less than 52. Yes, it is less than 52. So what we did is we either stay with this 3 or 1 plus the value present at this, which is also 3. So leave as it is, 3 only. Increment j here. Okay. So we check that 7 is less than 52, but same thing happens because 1 plus 2 is 3 only. Now we shift our j from this memory location to this memory location. Now 9 is less than 52. Yes, it is less than 52. So what we did is we take the maximum of the value present at this particular memory location or 1 plus the value present at this memory location. So which is 1 plus 3, which is 4. So effectively this location is filled with 4 and j is incremented. J terminates because it reaches I. So next what we need to do is we need to increment the ith memory location to this last value. And we start our j again from the starting. So j is again starting from this memory location. Now effectively fill this values. So 2 is less than 16, yes, so maximum of this is 2. 18 is less than 16, no, so increment j, so j will be here. 12 is less than 16, yes, so change this value to 1 plus 2, which is 3, and increment j here. 7 is less than 16, yes, so change this value to 1 plus 2, 3, so it is 3 only. Increment j. 9 is less than 16, yes, so change this value to either 3 or 1 plus 3, so which is 4. Increment j. 52 is not less than 16, increment j, and it will terminate, and I also terminate because it reaches end of this array. So effectively what we got is the longest increasing subsequence can be present in any of these locations. Okay, so the last step which we want to do is, see, what a student make mistake is they simply return this value. They simply return this value, but this is not true. We have to find the maximum value of all this. Okay, whatever is the maximum value, we will effectively return it. So when we take the maximum of all this, we see that 4 is the maximum value, and it is the longest increasing subsequence present in this array. Okay, so we return our answer as 4, and here we can see that we have taken, or we iterate over 2 loops. The I loop is the loop which is iterating from outside, and the j which is iterating from 0 to I. Okay, so we have taken 2 loops, so effectively we are taking a time complexity of O of n square, and we are taking an extra map which is memo of size equal to n, so the space complexity will boil down to O of n. Now let's look at the coding section of this, and I will show you how to code properly. So now let's jump into the code. So now let's see the coding section of this. We have taken a function longest increasing subsequence in which I'm passing an array, which is this array, and the size of this array. Okay, so now let's look out this, how we gonna do this. First we will have to check the base cases. For that we will check that if n is equal 0 or n is equal 1, then what we did is we simply return the n, because with 0 element or with 1 element the only possibility is that only, because that's the only one which is the longest among of all this. Okay, so we return that. After that what we gonna do is we will take a map which we called it as memo and initialize with the size as n. Okay, in this map we will store the value which we computed here, this map, this memo map. Okay, and as I discussed, we have to initially update this value with 1, because with 1 element the longest increasing subsequence can be possible is that element only. Okay, so what we're gonna do is for I is equal to 0 and I is less than n, I plus plus, just iterating over this array and filling the map value as 1. Okay, so this is the base case. After that what we gonna do is we gonna iterate in 2 loop, the outside loop I and the inside loop which will go from 0 to I. Okay, inside loop which we have taken as j, and it will go up to I. Now before updating the memo, what we're gonna check is if the value present at the jth memory location is value present at the ith memory location. So if this check is justified, then what we're gonna do is we're gonna update the value of I, memo of I, with maximum of memo of I, or 1 plus memo of j. So what we are doing effectively is, see, we have let's say our elements are 2, 1, 5 and 6. So what we're gonna do is we're gonna iterate I from here and j from j from here up to I. And initially we have filled all this value with 1, because with only one element, longest increasing subsequence will be 1 only. So we check that if 2 is less than 1, it is not, so we will do nothing and increment the I. J will again start from the 0th position. We check that 2 is less than 5. Yes, it is less than 5. We have checked this condition here, which is error of j is less than error of I. We check it here and we update this value with maximum of memo of I, the value already present here, or 1 plus the value present at this, because 2 and 5 it will give one more length to the longest increasing subsequence. Okay, so it will be 1 plus 1, which is 2. So this value will be updated too. That's what we have done here. Okay, after that, this iteration, our memo will contain all the values up to that length which has the increasing subsequence. Okay, lastly what we're gonna do is we're gonna return the answer and we initialize this with int min. Okay, or without int min, just initialize it with 0. Okay, and iterate over the memo map which is of length n, and just update the answer with max of answer and memo of I. So effectively this answer will contain the maximum length of the increasing subsequence, this answer. Okay, so in this case we have 156 or either 256, which is of length 3. Okay, and at the end what we gonna do is we simply gonna return the answer. So now let's check the output of this code first. Just compile it and gonna check it. So 8. So how this 8 is possible, let me show you. See, we can take 1, 5, 6, 8, 23, 52, 73, 521 and no, not this 520, up to this only, because this is not strictly greater. Okay, so we will not take this 520 up to this point. Let's count it: 1, 2, 3, 4, 5, 6, 7, 8. So we return the answer as 8 only. Okay, so now let's analyze the time and space complexity in doing this code. Here what we gonna do is we iterate into loop. The outer loop execute n times and the inner loop will execute on average n time. So effectively the overall time complexity will be O of n square, and we have taken extra array of size n, so space complexity will be O of n. So that's it for today's code. Hope you enjoyed it. See you in the next tutorial. Thank you.